Hi everyone. Today we're going to walk through, you can see the title up on the top, Quadratic Equations. I need to be a little clear about the purpose of today. We make the assumption, you guys walking in, that you're all pretty solid at being able to go through and solve quadratic equations. It is a big part, or was a big part, of your grade 10 course, and we've already reviewed it this year. So the purpose of today is to just kind of knock off some rust again as we get into using these more regularly. However, the second part of today is about how we can problem solve through it and how we can become more efficient at looking at the aspects of quadratic equations. So today is entirely a day of not like how do we work with this stuff, but can we work with it in a much better way? Okay, today is about process. It's not really about new theory. So what I want to do is I want to start off right away, and we're going to go through pretty quickly at the beginning. As I said, I make the assumption that you are good to solve quadratic equations. So I would like you to go through and solve the two quadratic equations that you see on the screen right now. Follow that instruction. We are solving for exact. Make sure that you are dealing with exact roots. Okay, give them a go. Pause it now. Okay, we're back. So I take a look at that first equation. I can't put my x's together into one term. And so since I can't isolate my x that easily, then I'm going to go through and probably look to see if I can factor. 2 and 1, I got my 4, my 3, there's a 6 and a 4. That's not going to work. So if I flip those, then there's my 3 and 4. I get an 8 and a 3. Yep, that works. If those signs, and we are good. So my whole process of factoring this first one should be pretty automatic. We should be good to then be able to jump to a therefore x equals 3 halves or negative 4. I just want us to be reminded again of, technically what we are doing is we are saying that we have something times something that equals 0. So we have a product that equals 0. And therefore, one of those factors must equal 0. Now, you've gotten so used to looking at that green theory that quite often we just jump over it, and you jump right down to that final red line to state that these are the values that make each individual factor equal to 0. Notice you can jump over the green. I'm not asking you to include that. If you only showed me the red, you have a perfect solution. It's important for us to remember, though, that that's our theory. A product equals to 0 means one of its factors must equal 0. All of that usage is encompassed inside that therefore statement. So make sure that you have a therefore on your final line. The last little reminder, take a look at your solution. Make sure that you still have that equals 0 up there. Notice that if you do not have that equals 0 as part of your solution, you don't have an equation anymore. You now just have an expression. That expression can have any value because the value of x can vary. That only because it equals 0 is the rest of your statement true. So, as I said, you give me the red, you are good. Okay, we take a look at problem B. In B, I'm going to look and see the factor. There's a 6 and a 1. That doesn't help me. A 2 and a 3. That doesn't help me. That does not factor. So, since I can't collect my x's into one variable term and it does not factor, then I am using quadratic formula. So, therefore, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I would expect that you would have that quadratic formula nailed down. That is background knowledge for us. Like that is the similar sort of process to you having Pythagorean theorem or you having area equals length times width. You don't have to show me that as a formula. That is background knowledge. So just use it. So your first line, I would recommend having this. You need your therefore at the beginning because we are applying a piece of theory, your quadratic formula theory. So therefore, x equals negative b, so switch the sign on the b, the square root of 4 squared is 16. Notice I don't even think negative 4 squared, because as soon as I square it, it's going to make it a positive anyway. So it's my 4 squared minus 4 times 2 times negative 3. Now, I just want to draw to your attention, that is going to be the most common mistake you deal with. When you look and you see that C value at the end, your constant, you really want, when it is positive or negative, to be jumping out at you. The fact that I see that that is a negative value, as my equation is in standard form, is going to remind me, oh, when I take that negative 4 and I multiply it by that negative 3, that's going to change that to an addition underneath my root sign. It's not even close how much that is the most common mistake. So we should be able to calculate our 4 times 2 times 3. So I'm going to get rid of all of that. I have a plus, because I can see the sign of my constant, and my 4 times 2 is 8, times 3 is 24. That is all over 2 times A, 2 times 2. Okay, my next line is simply to go through, yikes, and simplify. So everything I'm doing is just following BEDMAS. Now that expression pops up, and we should be totally good at being able to simplify that by now. We have spent so much time working with an expression like that no one is going to try to divide out your 4, because you see on the top that you have 2 terms, so you have to divide out a common factor from all terms. And we're absolutely not going to try to divide out a 4 from the 40, because that's not a root, or that's not a 40, it's a root 40. So no one is making those mistakes anymore. What we need to do is try to simplify that root. Well, we notice that that's going to be a 4 and a 10, so the square root of 4 is 2, can't take the square root of 10. And now that I have simplified that root, I'm going to be able to divide out my common factor. Divide out a common factor of 2 from every term, and there we go. So notice in the instruction it said to solve for exact roots. That means that I cannot round off anywhere in that process. There we go. So we should be good to be able to go through and solve both A and B pretty quickly. Let's jump in and deal with 2 more. Okay, same thing. I want you to go through and solve for both C and D. Okay, pause it now. Okay, we're back. So, quick peek. I can't put my x's together into one term, so I'm going to look to factor. That doesn't work. That doesn't work. In fact, some of you might even have looked and noticed that really all I did was, in problem C, I gave you the same equation. I just switched the sign of my constant. So it doesn't factor, so I am going to try quadratic formula. X equals, switch the sign on the B, 4 squared minus 4 times 2 times 3. I see that that's a positive at the end, so I know I'm subtracting. There's my 24. I now have 4. And I have everything I need there because of what I see here. Within that quadratic formula, within that expression, I now have to calculate the square root of negative 8. And I know that I can't calculate the square root of negative 8 because I can't take the square root of any negative number. And so that expression is undefined because I can't calculate it. So what does that mean when I can't calculate that value? Well, I'm trying to calculate the solution to the equation. And if I can't calculate the solution to the equation, then that means there is no solution. Now, you don't have to show me the green statement of undefined. You can draw the conclusion of no solution on its own. You would also see it sometimes, the actual statement to say that there's no real solution. It would end up saying that there's no real roots because roots is another word for that solution. For us to go through, you don't need to make this statement about real solutions, because all we work with is real numbers. It's kind of viewed as being redundant. You can simply state no solution and you are good. Okay, you show me the red and I need to see all of the red and you're good. Okay, let's jump into D. D, I go through, I can't put my x's together, so I'm going to look to try to factor it. I do factor that, and I know that that factors. Now, for some of us, in terms of our factoring skills, we might have been faster to use quadratic formula. I'm going to argue, I think that means that we need extra practice at factoring. However, I want you to be as efficient as you can be. So maybe we did go through and deal with quadratic formula to get down to a point where we found that we actually only have one solution. X equals 5/2. Now, there's so many different ways you could have written that. I would have hoped that everyone would have given me that blue. However, I acknowledge that I would still have a bunch of people that would write that down. I would just hope that we didn't say x equals 5/2 or 5/2, because that's redundant in horrible form. I hope we can see from that blue line that we absolutely, since having two of the same factor, would write it in the most efficient form. Now, I just want to draw to your attention, we could actually solve that equation by isolating now, because you can get your x all by itself pretty easily. So, what do I have to get rid of first? I've got to get rid of my squared. So to get rid of a squared, I take the square root. Square root of 0, 0. Now I could go ahead, get rid of my 5, get rid of my 2. Clearly, it's a longer solution. We should be good, since that is factored, to simply state, through our property, that x equals 5/2 and we're fine. So I'm hoping that you take a look at those 4 problems and we were good to be able to solve all of those. I'm going to argue to you that if we struggled through solving any of those 4, that's giving you feedback that we do not know how to solve quadratic equations well enough and we need extra practice in those areas. Okay, the rest of today is going to be working our way through and trying to address, can we get better with quadratic equations? Can I start to examine it, become more efficient, and more comfortable with what I'm seeing in front of me? So let's change gears a little bit. What you see on the screen now is something that I'm hoping you can recall back from grade 10. That is, we should have spent some time talking about the discriminant. The discriminant is what you see in red, b squared minus 4ac. I want to have a quick discussion so that it's not just something that we've memorized in our past, but we really, really understand why it's important to us. In order to do that, I want us to take a look at our green. You see in green, we've got our quadratic formula. And if I wasn't so concerned about what my solution was, but I was concerned about, can I solve the equation? And if so, how many answers would I get? Then I really want to focus in on that green. We should have just went through and reviewed within those first 4 problems that when we solve a quadratic equation, we can get 2 answers. That's what we saw in question A and B. We could get no answer. That's what we saw in problem C. Or we could get 1 answer. That's what we saw in D. That my only possibility of solving a quadratic equation, because it's degree 2, exponent 2, is I could get 2 answers, 1 answer, or no answers. So how do we now nail down the possibility of solutions? I want you to look back at the green, because quadratic formula gives us that key. We know we could use quadratic formula to solve all quadratic equations. It just doesn't mean that it's the most efficient way. We could have used quadratic formula on question A. We could have used it on D. I just hope we wouldn't. So what part of quadratic formula gives us our 2 solutions? And there's kind of like a quick little gut instinct answer. I want to really narrow it down to what really causes my number of solutions. A lot of people focus in on the plus and the minus. And I'll give the key that yes, the plus and the minus is what determines us having two answers. The fact that you're going to take negative b and add on your square root all over 2a, or take your negative b and subtract your square root all over 2a. We can see that the plus or minus gives us two solutions. But it's not really the plus or minus that determines my number of solutions. Because what I'm adding or what I'm subtracting, that's what determines my two solutions. So it's not really the plus or minus, but it's actually my root. This root b squared minus 4ac is going to be the bit that I'm adding on or that I'm subtracting off. So it really becomes like negative b plus a number over 2a or negative b minus a number over 2a. So it's that number that really generates my number of solutions. So what determines that number? Well, yeah, it's a square root. But it's really the value underneath the root that determines that for me. So I don't even really need my square root in that aspect. It's really what's under the root that determines my number of solutions. And so that's why you see our discriminant only being the b squared minus 4ac. What we need to do is examine for my number of roots, the plus or minus determines that. But it's the plus or minus of what that really determines my number of solutions. So let's focus in on that b squared minus 4ac. It's called the discriminant, you can make the argument, because it discriminates between the number of solutions you get. It's going to determine two solutions, no solution, or one solution. So what I want to do is I want to actually make like a little chart. We're going to make like a 3-column chart, but it's not a big chart. It's really small. But I'd like it to be in 3 columns. So what we could do is get 2 solutions. We could have no solutions, or we could have 1 solution. Those are my 3 possibilities when solving a quadratic equation. Okay. Before we get into our whole discriminant and what really nails down my number of solutions, I just want to talk about some language. You won't always see it as 2 solutions, no solution, 1 solution. I'm going to throw in all the ugly language that I've come across over time because you'll come across it as well. It can get really wordy at times. Like take a look at the first one. 2 real solutions can sometimes be told as 2 real roots. And we've already had the conversation over the use of the word real. I don't think we have to revisit that. It could also say like 2 distinct roots. Distinct roots. To say that those 2 roots are different. And that leads us down to the last column, because sometimes what you'll see is 1 real root for 1 solution, or like 1 double root. To kind of say like you get a root, it just shows up twice. So that's why you can often see, no, I've got 2 roots and they are distinct, or I have 2 roots and they are the same. So it's 1 double root. All of that is wording that is way too specific for what we're talking about in here and next year in advanced functions. So since we're always working with real values, I think we can nail it down to a 2 solutions, no solution, or 1 solution. Okay, let's zero in on that portion then. For us to get 2 solutions, that means the plus or minus has to be meaningful. It has to be effective. That means that I have to add or subtract a number that will cause a difference. So the only way that my quadratic formula can make my plus or minus be effective is if the number underneath my root sign my b squared minus 4ac gives me something that I can calculate, that then if I add something or subtract something, gives me two different answers. That means that I need my discriminant to be a positive value so that now when I add or subtract, I will have a number to do that with. So how do I get two solutions? I make my plus or minus mean something. That means my root has to be something that I calculate to give me a value where plus or minus matters. Okay, b squared minus 4ac must be positive. Okay, let's jump to no solution. Well, the only way that I can get no possible solution to my equation is if I can't calculate it. And within my green quadratic formula, the only way that I can't calculate stuff, well, I can always calculate what negative b is, and I can always calculate what 2a is, and I can always divide by a 2a. The only part where I can get something where I can't calculate is if I had a negative underneath my root. So how do I have no answer? It means my discriminant must be negative. Okay, let's take a look at our last solution then. This is one where it really tells me whether you understand why the discriminant is important. The only way that I can get one answer is if I make my plus or minus not matter. If my plus or minus matters, then I'll get two solutions. The only way I can get one solution, to still be able to calculate a solution, is to make my plus or minus not matter, not meaningful, not effective. Well, the only way I can make that not effective would be to add or subtract 0. Notice if I add 0 to something or I subtract 0 from something, I don't change the value. I'm still going to have the same number. So if I add 0, well then my root is going to be negative b plus 0, so why even write it, over 2a, or negative b minus 0, so why even write it, over 2a. I get the same solution, negative b over 2a. There's my one answer. So the way that I make one solution occur is to have my discriminant be equal to 0 because that's what nullifies my plus or minus. Therefore, the only way that I can have that be 0 is if what was underneath my root equaled 0, because the square root of 0 equals 0, and we are good. So I'm not asking you to memorize that little chart. I think that's the exact opposite of what I'm saying. I'm saying we should know that cold because we know our quadratic formula and we understand how we make some things important as we go. Okay, I want to transition now and start using that to see how effective we can be. So I'd like you to take a look at problem 2, and I'd like you to attempt all 4 in theory. Like we're not actually going to do it. Because I already told you, I'm assuming that you were good with all this stuff. What I want to do with problem 2 is I want us to examine how we would answer that problem, not what the answer is. And I want to go through my process, how I would actually go through to be efficient to answer each one of those 4. Okay, so let's take a look at the instruction. Instruction, determine the number of solutions. So I don't care what the solutions are, I just care how many. So I know I'm looking for 2, 0, or 1. Well, the first thing that my eyes go to is I take a look at the whole thing. Now, this is me because I'm pretty decent at factoring, that there's times where I will look at that and I will just quickly scan and see, is it factorable? My experience would tell me that simple trinomials, I can figure out whether they're factorable in like 3 seconds. So I catch myself scanning it. I don't think we're all there. So what would be my strategy then? Well, the first thing I do is I look and I see is my equation in standard form? Standard form means I'm going to have a positive leading coefficient, and then I've got my squared term, my single term, and my constant. So it's in standard form. So my eyes go to that leading coefficient, and I see it's positive. And then once I determine that's positive, I look at the sign of the constant. I see that it's an addition, it's plus, it's positive. And so I have two options. I look at this one, and me personally, I can see that that factors into x minus 4 squared really, really fast. Now, I see that. That takes like a second for me. And as soon as I see that that is a perfect square, then I know that I have one root. However, I don't think everybody is in that same speed. And so, let's say it was something that wasn't as easily factorable. Then my first approach, after I see that my constant's positive, is going to be, I'm going to calculate the value of my discriminant. Okay, so then that means that I have 64 minus 4 times 1 times 16, that's 64, that's equal to 0, and I know if my discriminant equals 0, therefore, in red, one root. That's how I would go through to solve A. I take a look and I notice it's in standard form. I see the constant on at the end. If I can't factor quickly, I'm using my discriminant to determine my number of roots. Okay, let's take a look at B. My eyes go straight to, yep, it's standard form. I have a positive on the end. In my mind, I can already see that that's not going to factor. So I go to discriminant. I won't even write that down. I'm just going to use it. So I take a peek. I have my 36 minus 4 times 1 times 7. I don't even calculate my answer. I just know that 36 minus something less gives me a positive value. And as soon as I see that my discriminant is positive, I know that I have two roots. Like if that actually was the quadratic equation I was asked to solve, I think I might even take like 3 seconds to calculate the value of my discriminant first to see whether it's even worthwhile for me to solve it. Okay, jump down to C. My eyes go, is that standard form? Yes. Now my eyes go to the sign of my constant. And as soon as I see that that constant is negative, I can say two roots. Now, we should be good with why I can say that, but I want to make sure we really understand why. The first thing that we should notice is if I was to go through and calculate my value of my discriminant, then I don't even care what b squared is. Regardless of whether b is a positive or a negative value, as soon as I square it, I'm going to get a positive value. Well, now when I calculate my 4ac, I'm going to take my minus 4 times a positive value. Remember, I know that that's positive because I looked to see if it was in standard form. Now when I look at the value of my constant, all I'm looking at is the fact that it's negative. And as soon as I see that that's negative, well, that negative times that negative means that when I calculate this, I'm really going to take a positive value and add it to another positive value. There's no way that I can get a negative out of that. And there's actually no way I can get a 0 out of that. And so I know that my discriminant will always be positive, and therefore I come in on my red statement of two roots. So I don't even need to do any of that gold work. The fact that that is in standard form and I have a negative constant tells me two roots. So I'm hoping we can take a look at that. Now, there is an alternate way that we can also take a look without even examining the discriminant to know that I can't have one root. The only way that I can have one root, like up in question A, is if it was a perfect square. Perfect squares are what give me one root. Well, if I expand a perfect square, my constant on the end has to always be positive. So there is another reason for why I can't have one root, why there must be two. So as soon as I see standard form, negative constant, I know I've got two roots. Okay, now we take a look at D. I recognize I'm in standard form. I look at the sign of my constant, it's a positive. That means everything's up for grabs. I could have two, could have one, could have none. D is one where I am going to calculate the value of my discriminant. So 4 squared is 16 minus 4 times 5 times 2. And as soon as I do this, and I see I'm going to take 20 and multiply by something bigger than 1, but maybe we even get to the point where we just say, okay, 4 times 5 times 2, there is a 40. I can see that I'm going to get a negative value. We can do that in our head. And as soon as my discriminant gives me a negative value, then I know that I get no roots. Okay, us walking through problem 2, I'm hoping that we've been able to kind of explain some ways where you can be really efficient on your number of solutions. Zeroing in on your discriminant can be a big help as you look at your number of solutions, and then when you're actually solving a quadratic equation, the ability to check, but also the ability to see whether it's even worthwhile. Okay, I hope that helps with us getting better at working with quadratic equations. The rest of today, I want to work through a little bit of problem solving. So it's going to look like we're going to change gears a little bit. So I want you to take a look at problem 3. 3 says, for what value or values that you see in brackets there, of k, does the equation 3x squared plus 4x plus k equals 0 have real solutions? So the whole key for us to be able to examine problem 3, you need to come up with a value or multiple values of k so that that equation has real solutions. Okay, I want you to stumble your way through this one if need be. We're going to work on this one on our own. I want you to pause it now. Okay, we're back. So the whole key on this one is that we need real solutions. So what that means then is that equation, I need to have the ability to solve it. Like we don't have to focus in on the real, right? Remember, the real is kind of the added in information. It just has to have solutions. So I need to figure out what values could k be so that I can solve that. Well, if I kind of use the fact that this is asking about like the type of solutions I get or the number of solutions I get, that leads me to my discriminant, that I actually want to calculate the value of my discriminant. More importantly, I know that if it has real solutions, then that actually restricts the value of my discriminant. That actually tells me that my discriminant has to be positive to give me multiple solutions, or has to equal 0 to give me one solution. That only if my discriminant is positive or 0 do I have real solutions. Am I able to solve it? That line that we just put down, that's all your problem solving. So like literally this, b squared minus 4 times a times c, my c happens to be a k in this case, that red line is your problem solving. Like that's really where you've taken some theory and you've applied it. Everything after that just becomes mechanics. Notice that if you go through and simplify each term, you actually ended up building up an inequality that we solved on the previous day. The rest of this is just mechanics. Okay, so 16 is greater than or equal to 12k. So when I divide out that 12, I'm going to get 16 twelfths. Let's divide top and bottom both by 3. And I get my k value is less than or equal to 4/3. Nice. Okay, this is not required as part of your solution. I'm just going to shrink this down a little bit to give me a little bit more room. But I just want to make sure that we understand what that solution means. That means if my k value is any value less than or equal to 4/3, I can solve the equation. So a couple things for us to kind of nail down. We see that equal sign. That should kind of drive us that we know if k actually equaled 4/3, that's what's going to get it to equal 0, the discriminant. That's what leads me to my 1 root. And you could check that. I'm not saying do that right now, but you could check that if you went and replaced your k with 4/3, you're actually going to be able to solve that for 1 root. Okay. What that also says then is that less than. That anytime k is less than 4/3, I'm going to now get my 2 roots. Now, you might look at that and I'd say, okay, so just like pick a k value that's less than 4/3. So the easiest value to work with that's really close to 4/3 would be like 1. So if I checked, like what if k equaled 1? Well, then that's going to give me this as an equation. And I just want you to notice that if I use my discriminant, 4 squared minus 4 times 3 times 1, notice that by me making that k value 1, it guarantees that my 4ac is going to be less than my b squared. And since it's less than my b squared, then I know that when I calculate that, I get a positive value, and that's what leads me to 2 roots. Now, you'll also notice, with just a little more detail, when I say it's going to be less than, that also affords it for negative values. Notice that as soon as I go k is less than 4/3, like a value of k that's less than 4/3 is like -1, -10, -1,000,000. K less than 4/3 encompasses all negative values. So also notice that as soon as I make that k a negative number, then from what we've discussed before, I know I get 2 roots. So as I said, that is not needed as part of that solution at all. But I hope that it gives us a greater context to what that solution of k is less than or equal to 4/3 really means. Okay, let's jump into one last one. So I'd like you to take a look at problem 4. For the function f of x equals, and now we got this big ugly f function. In brackets, we got our k plus 1, x squared, plus 2kx, plus k minus 1. So for that ugly function, for what value or values of k will the function have no zeros, 1 0, or 2 zeros? Now, we're not going to solve this one together today. I think this problem is very valuable for you to stumble your way through. It doesn't mean that this is a difficult problem. You could probably answer this problem in like a minute. Or maybe it takes you like 20 minutes. Or maybe it takes you a couple days. I need you to know that it doesn't mean because I'm leaving this with you that it's going to be this big, elaborate solution. No, I just think that it's very, very valuable for you that if we struggle at the very beginning, that we don't kind of lose that problem-solving aspect by you just watching me talk through a solution. I think it's worthwhile for you to stumble through that. So, I'm leaving you with that, and we're going to talk about the solution at a later time. That means this is done for our lesson. So now, How should you spend your time? Okay, go back to the very beginning with solving quadratic equations. If we were not automatic with that stuff, then that's telling you that you need extra practice solving quadratic equations. Maybe it's worthwhile for you right now. Don't even worry about question 4. You jump in and you work your way through some of that mechanical stuff before you attempt 4. Spend your time where it's most important. For anybody who at the very beginning, that was automatic, then I'm going to argue to you, work your way through 4, stumble. Try to problem solve through it. Maybe that means that you try it for the next 15 minutes. Okay, you don't get anywhere. Okay, then jump into your practice. Maybe come back later on tonight. Try it again. Maybe tomorrow, try it again. Keep revisiting the problem. Don't give up too early. I'll post a solution to problem 4. But as I said, I think it's very important for us to train that problem-solving instinct by just being able to stumble our way through. Okay, now that you know how you should spend your time, I want you to spend your time the way it's going to serve you best. Okay, good luck.